So we are going to learn about classification with neural network. We will learn about what is neural network and the general algorithm or the first algorithm for the neural network, and we will learn about the backpropagation algorithm. So first, we will check what is classification. You already know the classification in the previous chapters, but you do not know how to represent it in the mathematical formula. So I would like to explain it in the mathematical formula. As we know, the classification is the part of learning to predict the categorical class labels. And when we do the classification, let's say this is one example how we can classify the personal homepage. You know, personal homepage. So it's like a website. And the website, in the website, you can have a lot of information, maybe the information about the person, and then the story about the person, or maybe anything about that person. So I can have the X and Y. So X, usually we say this is a set of attributes. It can be X1, X2, X3, and so on. And Y is the target. So I want to know whether the person is an ordinary person, or celebrity, your name. How can we check that one? Okay, I can check from the number of words. I want to know how many number of words about drama. How many numbers of words about scenario? And this is the attribute number 2. And I have attribute number 3. How many number of words about child rearing? So child rearing is about how you take care of the child and etc. So the first person, they have many stories about the word drama, the word scenario, but for the child rearing is 0. And okay, we know that he or she is a celebrity. The second person, again, we know that the number of drama is 2, the number of the scenario is 13, and the number of child rearing is 1. And based on the data, the person is celebrity. But the number of drama is 2, the number of scenario is 3, the number of child rearing is 12. And based on the information that we get from the person of homepage, he is only an ordinary person. So if we have like this, so in the mathematical format, we can have this one as X. X is a set of attributes. And inside of the X, we have X1, X2, X3. So that's why this X is the attribute. It will be the element of the X. So the X1, X2, and X3 is the element of the X. And all of them are in the real number. R means real number. And what about N? N is the number of attributes. And we have the Y. Y, small y, belongs to the big Y. In this case, I have only 2 classes, 0 and 1. 0 is the ordinary person and 1 is the celebrity. So we want a function f. If I know the x, can I predict the y? So this is the mathematical expression. I know the x, and can I get the information about y. So when we have this mathematical mapping, then it will be easier for us to understand the general concept about classification. So the neural network, it is started by psychologists and neurobiologists. Neural, yes, it is from the word neuron. A neural network is a set of connected input or output unit, where each connection has a weight associated with it. Okay, we will check later. During the learning phase, the network learns by adjusting the weights to be able to predict the correct class levels of the input. So we have this input, and the weight will be adjusted to predict the output. It is also referred to as connectionist learning to do the connection between units. Connectionist. It means there is a connection. From this one and this one, there is a connection. From this one and this one, there is a connection. This one, there is a connection. Neural network is a set of connected neurons, and there will be some layers. We call input layers. This is the first input layers, and then we have hidden layer, and we have the output layer. This one. Okay. So the neural network is an algorithm inspired by the neurons in our brain, okay, because the word neural, it is from the neuron in the brain, and then it is designed to recognize patterns in complex data. Okay. Let's see an example. We have a model, input and the output. The input is sugars. How many sugars that have in one kind of food? For example, this is the grams of sugars per serving. So if you eat something, in the box you will see how many sugars. And if I know the number of sugars, I can know the number of calories. The calories per serving. We have the weight and we have the bias. So you can see from this one. X is any variable, or it represents the attribute. The value of that attribute will be multiplied by the weight plus the bias multiplied by the number, which is 1. And it will show the result. In the mathematical form, we can have y, it is the result of w, which is the weight, multiplied by x, x multiplied by x, plus the bias, b multiplied by 1. So I can have just like this one. This is what we call as the linear unit. If we have like this formula, that's it. We could estimate the calorie content of a cereal with 5 grams of sugar per serving by using like this one. If I know that the weight is 2.5 and the bias is 90, and let's just assume that the bias weight is 1, like this one, the information is 1, and this is the variable sugar. Now I have the information, the weight is 2.5 and the bias is 90. And I have the information that 5 gram is the number of sugar per serving. And how many calories do we have? we can just multiply 5 multiply by 2.5. So this one 5 multiply by 2.5 plus 90 multiply by 1. So what is the result? This is the result, 102.5. Okay. It means this kind of node represent a kind of mathematical formula, and you can get the result. Now, if we have like this, what is the formula? Y equals to W0 multiplied by X0, and then W1 multiplied by X1, and then W2 multiplied by X2, and then plus P. What about this one? Well, it is more complex. We have Y0 and we have Y1, and each of these tens will be connected. Then let's say if the blue one, maybe I can say this is W00, this one W01, and then this is the bias 0. Then Y0 equals to W00 multiplied by X0 plus W01 multiplied by the X1 plus B0. And if let's say the red color here is the W10, and this one is W11, and then this is W12, or you can say just the bias 1. Then Y1 equals to W10 multiplied by the X0 plus W11 multiplied by the X1 plus the bias 1, and so on. We call this is a dense layer of two linear units receiving two inputs and a bias. We can have a lot of networks. So this is the architecture. If we have only one input layer and if we have only one output layer like this, then we call this is a single layer neural network. If we have input layer and we have one hidden layer and we have output layer, we have only one hidden neural network, then we call this is multi-layer neural network with multi-layer perception. So sometimes, yeah, they call just MLP, multi-layer perception. If we have many hidden layers, this is hidden layer 1, this is hidden layer 2, this is hidden layer 3, and so on. Then we call this deep neural network. The deep neural network, it is the basis of the deep learning. If you know a lot of things about deep learning, the basic idea is from this one. You have the input layer and you have the output layer, and there are many hidden layers. So there are several types of neural network. Different types of neural network use different principles in determining their own rules. What we are going to study more is about the feed-forward neural network. The feed-forward neural network is when the data passes through the different input nodes till it reaches the output node. There is no back propagation algorithm. It means, like this one, if you look at this developer, we start from the input and then we go directly to the output and finish. Radial basis function neural network. The radial basis function consider the distance of a point with respect to the center. So the idea is almost the same with the clustering. So they try to find the center. So you can see this one. So they want to find which is the proper center, and then after they find the proper center, they want to find the linear combination of this radial basis function of the input and the neuron parameters. There's another kind of neural network, they call it coherent self-organizing neural network. I will not discuss in detail. So they just built a coherent map. It is based on factors, and we can make the factors arbitrary dimension to a discrete map made of neurons. So this is, you can see the way of the coherent self-organizing neural network. There are another type of neural network, we call it RNN, or recurrent neural network. The RNN works on principle of shaping the output of a layer and feeding this back to the input to help in predicting the outcome of the layer. So if you see this one, we have the input, and after we have the input, we are going to check not only one time, but we recurrent. We check again, we check again, we check again. After some period of time, then they will show the output. There's another type of neural network, we call it the convolutional neural network, or CNN. CNN are similar to feed-forward neural network, where the neurons have weights and biases that are able to learn. So if you look at this CNN, so this is a type of CNN, or the convolutional neural network. If you have some data, they will select only partial of the data and they will say convolute. Convolute, it means they will make a reduction, and then they will make another reduction. They will make another reduction until they can find a good pattern from the data reduction. So I'm not going to discuss all those neural networks. So we are going to focus on the feed-forward neural network at this moment. So the feed-forward neural network was the first and the simplest type of artificial neural network. This multi-layer feed-forward network consists of input layers, one or more hidden layers, and output layer. Each layer is made up of unit or neurons, and there are connections between these neurons. We call it weight. So we already learned from the previous example, we have the weight. We have the W. It is the weight. And we have the n-dimensional input factor x that is mapped into the variable y. So we still remember the f function. We have the x will be mapped into y by means of the scalar product and nonlinear function mapping. Nonlinear function mapping, it means there will be another function. So the function is represented like this one, not using the linearity. The inputs to units are output from the previous layer. So if we have this input, it will go to here. We will do calculation. After we have the output, it will be used for this output. So this will be the input and this will be the output. After we got the numbers, this will be the input and this will be the output. And after we do the calculation, then there will be another output. They are multiplied by their corresponding weights to form a weighted sum. So if we have weight, so we will do the weighted sum, and then we will add some bias, which is added to the bias associated with the unit, and then a non-linear activation function is applied. So we will have another function which is called as activation function. At the end, we will get the output. So this is how the multi-layer feed-forward neural network works. The first is the input to the network correspond to the attributes measured by its training input. So let's say I have variable 1, variable 2, variable 3, variable 4. So this represents the attribute. Input are fed simultaneously to the units making up the input layer. So this is the input layer. They are then weighted and fed simultaneously to the hidden layer. So there will be weight, there will be weight, there will be weight, there will be weight, and there will be weight, and so on. It is the hidden layer number 1. The number of hidden layers is arbitrary. So there is no proper numbers of the hidden layer, although usually only one. If it is only one, then we call it the multi-layer perceptron. If there are many, then it is the deep neural network, DNN. The weighted outputs of the last hidden layer are input to units making up all the output layer, which emit the network's prediction. So after you reach this one, then there will be the output, and the output is the prediction result. The network is feed forward. Feed forward means like this one. You have the first part, the variable, and then it goes to the next, it goes to the next until the last one. So we do the classification. And every of this input, it will go to the next layer. This layer have input to the next layer, and it will have output. Then this will be the input to the next layer, and so on. And none of the weights cycles back. So after we have the sequence finished. From the statistical point of view, networks perform non-linear regression. Given enough hidden units and enough training samples, they can closely approximate any function. So let's see one example. We have like this one network. We have x1, we have x2, we have n1, we have n2, we have y out, and we have p1, we have p2. Okay. If you look at this, n1 will be the output. So I can make the formula like this. N1 equals to minus 2 multiplied by x1. Minus 2 multiplied by x1 plus minus 2 multiplied by x2 minus 2 multiplied by x2. So it gives the input here plus the bias 1. The bias 1, if it is 1, then we can just see this one, 3. What about the n2? n2 is 2 multiplied by x1, 2 multiplied by x1 plus 2 multiplied by x2 plus t1. t1, it means the arrow from the bias, and we will check later the weight. In this case, -1. In this case, it's 3. And we have the n1, we have the n2. Now we have the y out. What is y out? The y out is the result from the previous one, which is n1 and n2. So the formula will be 1 multiplied by n1 plus n1, 1 multiplied by n2 plus the p2. p2 here, it means -1. Okay. Now let's suppose I have x1 like this, and I have x2 like this one. And I have the data with the true output. This is given. Okay. Like in the classification, the iris data set, we have the true output, which is the flower name. Then this is the true output. For example, I have the x1 is 0 and the x2 is 0. And the true output is 0. Now, I would like to put into this network the n1 result. n1 is using this formula. Then I know the x1 is 0. So x1 is 0 multiplied by -2. This is the weight. Plus 0 is from the x2 multiplied by -2, which is the weight. Plus 3. 3 is the highest one. So we can get the result. It is 3. What about n2? The n2 is, again, we have the x1 is 0, so 0 multiplied by 2. Okay. 0 multiplied by 2 plus 0 multiplied by 2 plus the bias. The bias is -1. Okay. And the result is -1. Next, we want to check the y out. This y out means, the result is the prediction or the predicted result. This is 1 multiplied by n1. What is n1? In this case, we have 3. So 3 multiplied by 1. And then 1 multiplied by n2. What is n2? n2 is -1. So -1 multiplied by 1. And then plus bias 2. Bias 2 is -1. Then we have -1. Then the result is 1. Then from here we can see that the true output is 0, but the predicted result is 1. Then there is a difference. There is a gap. Let's say I'm using this loss function. This loss function is 1.5 divided by y. Y, it means the actual output or the true output. Y hat is the predicted output and power output. So the true output is 0 and the predicted output is 1. Then we will see like this. 0 minus 1 power of 2, then it is 1. 1 divided by 1 multiplied by half, then the result will be 0.5. Then the loss function for this row is 0.1. The next, you can just do the same procedure. we have the x1 is 0, we have the x2 is 1, then we can have the result is 1. The true output is 1, then the loss function is 0. The predicted result is 1, the true output is 1, then we can have the loss function is 0. The true output is 0, the predicted result is 1, then we can get the loss function as 0. And at the end, we can just sum all the loss. 0.5 plus 0 plus 0 plus 0.5, then the result is 1. If you want to use Python to deal with this neural network, so this is the example of the Python code. Actually, when you are doing with this neural network, you need to use the activation function. So the previous example, in this case, I do not use the activation function. Actually, when you are doing this, whenever you do this one, and then you do this one, plus the bias, and after you finish with this calculation, you need to do something with the activation function. So that's why I didn't use equal, because there should be one activation function. If we do with the activation function, the calculation will be more complex. So I skip the activation function. So based on this one, we need to have the one activation function. But I skip this. So this is the Python code with one activation function. We call it sigmoid. F is using this function lambda x and so on. And then we are making the input x. X is the random number. So we have 1, 2, 3. So we have 3 numbers. And then we want to fit this number into the hidden layer 1. So the hidden layer 1 is a function from this one. And we are going to make the dot. Dot means the scalar multiplication from the weight multiplied by the x. So this is the x. And you know the weight. And you multiply with the weight plus the bias. And we will get the result of the H1 or the hidden layer 1. What about the H2? The H2 is also the same. We are starting with the weight 2. Okay. H1 multiplied by the weight for every weight of this one. And then we plus with the bias 2. So we get the result in the H2. And this is the output. The output is the result of the W3. So it means this one, this one, this one, and this one multiplied by the H2 plus the bias 3. So this is the Python code to represent the feed forward neural network. And we need to understand that every kind of learning approach, we should choose loss function. The loss function means that before we train our network, we first need to quantify how good it's doing so, how good it is, so that it can try to do better. So if the loss is near 0, then that's the best. If the loss is very high, then we need to again repeat until we get the lowest loss. So the loss function or the error function or the cost function, it is a function that tells us how good our neural network for a certain test. Importantly, the choice of loss function is directly related to the activation function used in the output layer of your neural network. So if you use like the sigmoid, then there will be their own loss function. If you use another activation function, there will be another matrix. So we can have like three kind of problems: regression, binary classification problem, and multi-class classification problem. Do you still remember what is it? Regression. What is regression? It is when the target is numerical data. Okay. Binary classification. Binary classification, it means when we have the target, there is categorical data and only two options. Okay. Multi-class classification. It is the target when we have the categorical and we have more than two options. So if we have only two options, then we have only 0, 1. Yes, no. That's why we call it binary. If it is multi-class, then it is more than 2. Maybe we can have like the class small, medium, and large. Or maybe high, medium, low. So if there are more than 2, we call it multi-class classification problem. And most machine learning algorithms use some sort of loss function in the process of optimization. Or we call it, this is finding the best parameters or finding the best weights for your data. Better prediction means the lower loss. So I gave you this 3 loss function. The function that we had before is the regression loss. The regression loss is how we can see the difference between the actual value and the predicted value. And then we do the square and multiply with half. For the binary classification, we use the log function. Now I want to know the log function based on the probability when we can get the predicted value given by the x. We can have like this function. Y, it means the actual or the true output, the actual output. And the y hat is the predicted output. So it is like the probability that the y appears, and this is the probability that the predicted output appears. So you can put this formula. And if it is multi-class classification loss, we can use this formula. You do not to memorize this one, yeah, as long as you know that this is the multi-class classification loss, because in the Python you can just call the function and you can just run it. Okay, I think I will stop here. Any questions, comments?